G'day, I'm from Australia. My name's Patrick Smith. Today I'll be presenting GoldenOrb, which is a library. It's not published yet, it's sort of been in progress for this conference. It's to make UI components built in WebAssembly that are framework agnostic. So who the hell am I? I'm an application developer. I started off coding, I think in 2003, just had a Macintosh at home and just like coded stuff for just exploring. And so the first things I made were really desktop apps and then sort of websites, and there weren't many Mac app developer jobs, so I ended up sort of transitioning to the web. And then the desktop and mobile is quite similar, so I've made a couple of mobile apps. And the core belief of mine is that the user experience is everything. I think in the past decade or so, like developer experience has really become a big sort of craze, but I think maybe a little bit too much, even though it's nice to have nice tools. But for me, I have like a sort of user-centered approach. So things should be fast, should be robust, should be reliable. It's all about the user. So there's three things, at least for the purposes of this talk, but I like to get inspiration from outside of just like programming. Like I could read books, like I've made a WebAssembly compiler, and I've read some stuff about compilers, but you know, should probably read some more. But I like to get stuff from outside of these areas, because they're just going to introduce new ideas that you're sort of never, the usual ways of thinking are just never going to have. So three things: cellular life, React, and game engines have been inspirational. And so here, three books I recommend reading. The first one is on like how DNA sort of is critical to life, and you know, sort of how it works. It's quite a lightweight book, but yeah, it's got this life of like life is chemistry, life is information. It's actually quite inspiring, because in some ways I can sort of squint, look at DNA, and go like, hey, if this kind of fairly basic thing can create life, I can kind of squint and see WebAssembly in the same way. Like WebAssembly is very restrictive, so yeah, that's sort of quite inspiring. And then yeah, these two books as well, sort of similar themes. And then React's, I imagine everyone here has heard of React. It's sort of taken over the world, and its component model was really influential. I think it's really positive. Just it's sort of a very simple way of constructing apps. It's like, again, very restrictive, but once you sort of embrace that sort of constrained mode of just these declarative components, being able to, like, I remember the first time like app being a component, I was like, is that going to work? And it did. So that was pretty mind-blowing. And obviously the ecosystem in React is extensive, and that's why I think it's really the default choice for a lot of web apps. And one library in particular, React Aria, I think is like the gold standard for a component library. And so I kind of wish there was something like that in Elixir and in other frameworks as well. But I think one little negative thing is that Rec can be a little bit bloated, or just the culture sort of in the sort of modern JavaScript world can be a little bit inefficient. So that's always sort of nagged me a bit. And just the tooling's like very heavy and convoluted. And so if we want to make things more efficient, game engines are a great source of inspiration. They've got different ways of allocating memory, but they've also just like, they're like rebuilding the world like every 60 frames. They're like rebuilding the world. And it's like absolutely crazy. But I find it kind of ironic. I don't have an example here, but I imagine if you like played a AAA game, like that thing's going to like have like ray tracing and be like incredible. But if you go to the game's website, you probably scroll and it's like kind of slow, and it's like, well, one's like rendering these like high quality 3D graphics, and the other's just rendering some images and some text. And us web developers are somehow like making a slower experience. So that I find quite frustrating. And in games, especially like AAA games, like performance sells. Like they will say like, this one feels a bit last gen, like this one's really pushing the limits. So like if something is fast, it can win over users. So why WebAssembly? I sort of covered this last year in my talk last year, but I think for me, it runs in every browser, it runs on the server, runs on native. And so that's one of the things, those first 2 points with JavaScript are why it often is the default choice. But one of the benefits of WebAssembly, it's really fast and it works identically across all platforms. And so have you ever just laid back at the clouds and as you see a seahorse or a hippopotamus in the clouds there, have you ever just wondered to yourself, what is in a .wasm module? Probably not, but if you ever had, if you ever have seen these .wasm modules, you might have seen like you load a modern web app and it might download one. What's inside this thing? So there's, this is how, like when I first started learning WebAssembly, I'm like, how complicated is this thing? And this is what I've essentially boiled it down to in my head. There's these mutable global variables, there's a big array of memory, and then there's functions that let you work with those things. And then you can export each of those three things out and you can import them in. And so sort of WebAssembly sort of expects there to be some sort of host, some sort of thing above that's going to be doing the real work, I guess. And but it's yeah, this is the mental model. So if you ever go like, God, what's WebAssembly? Probably sounds really complicated. It's essentially just this. So just check for time. Yeah, good. So if you were to make a WebAssembly module today, you're probably going to use an off-the-shelf toolset like Rust, Zig, C, TinyGo, and think these are valid choices. I'm not going to dissuade you from choosing them. I'm not here to sort of diss them, but the way that these things work is that they basically compile to like native code. They take it, they compile to many targets, and then WebAssembly is just going to be another target that they just output. And so this means that they might be a bit more bloated than something sort of designed for the web. Like the web things should be really lean. So it might be like really, really fast. It might be but it might be a 2 megabyte WASM module. So they're also usually tailored for like a specific host. So it's like you're going to use some sort of like Rust WASM bind gen, and it's going to create all this like boilerplate to like connect to the browser. And they compile ahead of time, which contrasts to the library that I made, which is designed just for WebAssembly. It's sort of like starts with the ingredients of WebAssembly and makes them accessible. It's designed so it's because it's like tailor-made. These things are going to be like really small, kilobytes, not megabytes, and there's more exploration to do here. But I want to make this stuff like agnostic to what it's running on. So you could like maybe run these on mobile, run these on the web, run these on the server, run these wherever. And it compiles on the fly, which I'll explain a bit more, but it's essentially in the same way you just like render a bit of JSON or HTML on the fly, we're doing the same with WebAssembly. We just like every request response, we're like making a new WebAssembly module. And so that contrasts to something where we just having to like pre-bake it. And so I think there's two roads to adopting WebAssembly. So you can sort of see these are the two paths you have. So you either, if you really fall in love with WebAssembly, you might think, oh, let's rewrite everything in WebAssembly, or like take an existing language and like compile it out. Or I think the other option, which is what I'm advocating, is to use it for like strategic things. And so these things might be components, validation, formatting. There's some stuff I really want to do in the future with like syncable state, because you could have this like state on the server and the client. And if it works identically across both, then like maybe it can migrate from one to the other, like sort of almost like a save game, like sort of be saved in the client, migrate back to the server, be restored there, and so forth. So I think like there's interesting things to WebAssembly that are unique, unlike any other tech I've seen. So I think that's really cool. But today we're going to be looking at components. And so the way I think about components, which is why they're so, like with React, why it was so influential, it was restrictive. You just write out what this thing is. You just like write out this JSX, this declarative description of what you want to appear on the screen, given a set of props or state. And so you say like what the state is explicitly, but it's not really owned by you. You're not like sort of creating a class where like there's these instance variables. It's sort of like, hey, use state, and here it is, you can change it, but it's actually not really owned by by you. It's sort of just like surfaced for you. And then the events sort of work the same way. And then so all the actual magic is done by what I call like an engine. So that's what React, the value of React is like it manages the DOM for you. And so you just declare these things and then it helps keep it up to date. So when the state changes due to an event, you're going to have a new description of what, and React just takes care of all of that for you. And so as React has shown, you can compose these things and create an app. So if we had these sort of 4 ingredients, here's some examples. So React's at the top there. If you just like look at a traditional web browser, you can actually sort of think of that in the same way. Like I've actually sort of gone back and appreciated old school 90s web forms a bit more. But yeah, so like URLs, state, events you can use using the browser's form. And then of course LiveView, you can see how they sort of all align. And then what I'm showing today is a system using WebAssembly and Orb. And so yeah, those you see in the middle there, there are 2 ingredients of WebAssembly that I showed before, globals and functions. Like these play a critical role in making this work. And so we're going to use custom HTML elements to help make this work. And so this is a new, also called like web components. And so this is a primitive that's built into every web browser. And I think it really should deserves more attention because like I think LiveView is going to, heard from Chris that there's going to be like more better interrupt with like custom elements. So hopefully like as lots of different things like speak, custom elements, like all this stuff should work together. It becomes like a protocol. Like if you implement a custom element, then this stuff that's designed to work with them will interrupt really well. So I think it's time for a demo. And so I'm starting with the most basic demos. I'm not expecting everyone to be blown off their chairs, but the one of the things that's critical to me is like accessibility. So here's a menu, and I'm using my up and down arrows to like open, to navigate through this thing, and you can see it like wraps around. So this is like trying to do best practices with accessibility, and like if I like close the button and have it focused, I can press like the down arrow and it opens and so forth. And so you can see here that I actually show you, like I'm not expecting anyone to sort of understand this, but you can actually like view source. I love the sort of old school web of like view source. So this thing fits into like 2 kilobytes. And if you want to, you can like scroll through here and you can sort of see like, hey, there's like kind of little bits of HTML here. And so that's how this works under the hood. It's just smooshing some HTML together. And then there's some state of basically like, hey, when this thing's like open and so forth, they're the globals that manage that state. And so if you're to look at the, like WebAssembly is the thing that renders the HTML, but how is this thing like interactive? And so this is what GoldenOrb brings, is like a system of declaring events on your HTML. And so it sort of looks like the PHX attributes. And so you can see we've got like ARIA attributes for doing accessibility, hopefully properly. And then you can see here we've got like data action on line 7, like, hey, when this button's clicked, open or close the menu, like toggle it open. And then when the arrow down is pressed, we're going to like sort of not filled in to sort of basically like fall back to the action. Okay, when the arrow down is pressed, then toggle it. And if the arrow up's pressed, then we're going to focus the previous item. So it's this declarative way to sort of tell the engine, okay, what to do given an event. What do you want me to do to the tell the WebAssembly instance? And so you can see some more examples here. So these end up mapping. So you can see here in line 8 of the right-hand side data, key down, arrow up. So when the arrow up is pressed, we're going to call focus previous item. And so on the left-hand side is in orb code. So this is like an Elixir. You can see here when previous item is called, we're going to focus on the -1, go back 1 in terms of the item to focus. So we've got these sort of 2 worlds here, and we're bridging the 2 with this declarative system. And so if you're to try to illustrate this in a chart, up the top, is like the web browser and the like the user, and at the bottom is the WebAssembly. So if we we're probably going to start technically in the left hand there, because we're going to have some initial HTML, render HTML. But yeah, at some point the user's going to get bored and click on something, so you're going to receive an event. That's going to then look up that export by name, by that like data action or data key down. Look up the name. It's going to then go to the WebAssembly instance, find the function that was named that, call it. The WebAssembly thing's going to update its like internal state. Then it's going to have new HTML, and then we can update the DOM. So we're going to use morph DOM, which is what LiveView uses to keep the DOM up to date. So if you sort of have that loop going, like now it's magic. Like now users go, yeah, oh yeah, this is an interactive widget. So and so you can think of this as like the unidirectional cycle of life. So like React's like unidirectional, where you don't have two-way binding, but so it's this continuous loop that goes round and round and round. And it's, for me, it's like proven that this model works. It's like as simple and naive as it first sort of seemed when it first came out. Like this actually works really well. So this you can read through the bullet points. I won't talk through those, but it's essentially that same diagram of the different steps there. So here's a more ambitious demo. So common problem is like you've got some sort of form, and you want to populate that form, say with like a list of all the states, you know, like all the American states. Don't test me on them, but I'm sure the Americans here could know all 51 of them. So, but yeah, you want to have this sort of like data. So here's a CSV that I've pulled off GitHub. And I would like this to be populating a dropdown, an autocomplete dropdown. And so I'll go US first. So that's what I've got here. And so if you click here, you can see like all the states are listed there. And if I go like here, I've got autocomplete like typing, you know, C. There's a few states that start with C, and so forth. This is all coming through. So this is all WebAssembly. So it's the same system, declarative system that I showed before. And yeah, every time I type a key, it's going to tell the WebAssembly instance to go like, hey, the user's typed NO or whatever now. What HTML do you want to render? And it comes out and updates the DOM using morph DOM. But we can go further. So say if we want to, that's US, but say we're in Australia, we can do the same thing. So it's the exact same code under the hood, but there's this locale being passed in the URL here. So locale equals AU. And so we're going to see Australian states. And we can go, shout out to Mexico, we can do Mexican states as well. And so this is, I think, a critical thing is that, you know, we want to localize these widgets. But this is the exact same code. So what's actually happening here under the hood is that we're using rec from Elixir to load the states from GitHub. So actually when I reload the page, it's actually loading that from GitHub at that point in time. And then I'm going to parse it using Nimble CSV. We're going to initialize that in WebAssembly, and we're going to loop over that, basically like inline it into the WebAssembly, and then like compile it on the fly, send it down, and then the browser's going to take over. And so yeah, you can see it's like really fast. So, and if you're interested, you can like view source here, and you can see here are the Mexican states like inlined into the WebAssembly. And so here's like a flow diagram of what I just showed. So yeah, we can use all like the Elixir stuff at like compile time. So we can do whatever. Like we could talk to a microservice or whatever we wanted to do. We could talk to an API. Yeah, it could be totally dynamic. And then we're going to compile this thing on the fly. It's using Phoenix controllers to like serve the WASM, and then finally it ends up at the web browser. And so just another demo here. And so, like, yeah, here's React Aria. You might have seen the docs. It's like this is like the world-class standard for accessible components. And so I've got a way simpler version of what one of these widgets. So here's a calendar. So like, can go through any date, and I'm rendering up the correct days for that given month. And so. Yeah, I'll just show you. And so like that's in 2.5 kilobytes. So like everything's self-contained, like all the date maths and everything's like self-contained. So like this thing's like really small. So critical to me is like these things aren't like, oh, suddenly we're shipping like 50 kilobytes or like more, 0.5 megabyte of stuff just to get basic functionality. Like we should be able to work out a way to make these things lean. And so the title did say AI, and so I tried this various ways of doing this. I actually tried to make an interactive thing where you typed a prompt, and it's quite hard to get right, especially on the Wi-Fi here. But here's a pre-baked version. So yeah, told Claude to like basically given one of these examples, like given I think the combo box in the menu, like here's some examples. Here's some things you should do. Here's something anti-patterns that you should avoid. But like, hey, I just want to basically have a tab component. So here's this declarative system. Learn it. It's pretty intuitive. Can you make a tab component? And it worked. And so this it generated the Elixir DSL code for it, and then it was able to be compiled. And yeah, here it works. And you can see like even I've got this like keyboard, so I'm going left and right. Like it's worked out the accessibility for that as well, which is really cool. And yeah, 2,000 bytes, 2 kilobytes. And I've got just one more demo here. There's the combo box. I think it's like important that this stuff, you're not just locked into a framework. So I've tried to make this like framework agnostic. So here's an example of that combo box working in React. That does need, we'll put my hand up, like, obviously you can get away with some stuff in demos, but like I need to work out the event system. But yeah, you can see like this is actually rendering in React. And yeah, because React has good support for web components, which is getting better and the next version. And so you can sort of see like if you're in a React ecosystem, you can use these widgets as well. So that's why I haven't like made this specific to any framework, because frameworks might change in the future. We all love LiveView, but it might evolve in the future. So this stuff's really trying to be agnostic. And so if you forgive my ego here for a bit, but yeah, we've got this, what I call the Orb cinematic universe, but essentially there's 3 pieces here. The Orb WebAssembly compiler, which lets you write Orb in this Elixir subset, or this Elixir DSL. That's going to then compile the WebAssembly, and WebAssembly is so bare bones that it's just integers and floats, and like it doesn't give you anything. So I had to create like a bit of a standard library to like give you some stuff to actually do. And then now we're starting to actually use this for real use cases with UI components. So that's GoldenOrb. And so one of the problems with the standard library is that I need to implement this thing, and there's a fair amount of algorithms. So here's my technique. Orb, by the way, is named after orb weaver spiders. And so yeah, here's I think it's an Australian spider slurping up. So we're plagiarizing using ChatGPT to find well-known algorithms and re-implement them in Orb. And so one cool thing is like, if I generate an implementation, how the heck do I know it's actually working properly? So here's an algorithm for doing like a checksum, CRC. It's used in PNG, which I eventually want to be able to encode. And so like Erlang's OTP has CRC built in. So what I can do is just generate a whole bunch of random inputs, check that my version and the version that's been in Erlang probably for like 30 years, if they agree and like I have a wide enough range of input, I'm pretty confident like the one I just implemented actually works. And so you saw that calendar there as well. And so like the code here is some of the code to, I think, tell you what the weekday, the day of the week is. And so you can see it's like this whole bunch of wacky maths. And so ChatGPT was pretty confident that that was correct. But yeah, that's a whole, those numbers could add up to anything. So what I end up doing is in using XUnit, again, compared the Elixir version to my WebAssembly version, and with 1,000 random dates, the test passes, they agree. So yeah, so I'm pretty confident that works. So yeah, so I'm able to sort of I need to sort of accelerate this because I need these building blocks, I need these things to be able to build the stuff that I really want. And I don't, yeah, and especially for stuff that's sort of well known, I don't want to have to sort of reinvent the wheel. And so I think this is sort of a peek at the future. This is where I really want to get to, is you saw that AI generated component. I'm sort of curious about AI and what people's thoughts are, but I could imagine a version of that where you just type a prompt and it generates a component. I think that could be useful, but I think more as a tool. I think, yeah, I think just this idea maybe of just sitting back, you don't have to do any work, you just get the Jira card and then you just copy and paste the Jira description in and it spits it out and you punch in that you did 8 hours of work. I don't think that's the future, but I think it is a tool that we can use this stuff for. And so how do you know the thing that's been generated is correct? I want to check the accessibility. There's tools like Axe that I can use to verify this thing's actually proper. And so yeah, this is what I really want to sort of explore more in the future. And yeah, I just want to say a big thank you to Livebook for bringing me out here all the way from Australia. So Livebook combines great people with leading tech to help businesses build ambitious software applications simply, efficiently, and sustainably. We work with clients around the world, and we specialize in web development, distributed systems, and wrangling complex software requirements. So yeah, big thank you to them. And I think that's it. I've made it to the end. And yeah, and so please, I've got a website, put a fair amount of effort in, use orb.dev, check that out now. It sort of walks you through lots of different examples of using orb. You probably noticed I didn't show much orb code. That was sort of last year's talk. But yeah, I'm happy to take questions now.